Thank you, Timo. Good morning, everyone. So I will start by explaining you the example. The example that we will deal with this morning is a simplified yet real-life example. It consists in an excavation, a 5-meter deep excavation in Switzerland, in the French part of Switzerland, near Yverdon-les-Bains. And you can see here the extension of the basement here, and you can also see that there is a sensitive building close to this excavation. And the challenges are, of course, well, first of all, to design the sheet pile wall and the bracing, but also to check that the vertical displacements of the silo will not exceed a certain value. So you can see here the excavation stages. So you have first excavation and the installation of the strut here. Then you have the second excavation, and finally you put the blocking mat here and you remove the strut. You can also see that there are a number of different geotechnical units here. You have a backfill, you have palustrine deposits, which are quite bad, and then finally you have glacial lacustrine deposits. This is the design which was proposed by the engineers here. So you can see that we have this sheet pile wall here, a 12-meter deep sheet pile wall. Then here you have the excavation, and you have this one level of struts, which is here. You can also see somewhere, well, maybe it's when it's in French, but anyway, there is water here, so we will also introduce uncertainty on the water level, and that's the design we want to check now. About the soil properties, we have had CPTU tests here, and again, you can take a look at this specific geotechnical unit, which is the palustrine deposits, which has rather bad properties compared to the backfill and to the glacial lacustrine deposits. And then if you take a look here at the geotechnical report and the characteristic parameters from the geotechnical report, this is of course still the old way of defining these characteristics parameters. Then you can see, for instance, the friction angle, characteristic friction angle, and characteristic cohesion. And again, if you take a look at the palustrine deposits, you see that there is a very low friction angle, rather low cohesion, and also very low elastic modulus. So what do we have here? We have poor soil conditions. We have an uncertainty on the water level, and we have this sensitive silo, which is located a little bit behind the excavation. And the question we want to address here is more a serviceability limit state than an ultimate limit state. It's more SLS than ULS. Is what is the probability that the silo's maximal settlement will exceed 25 millimeters? Because the structural engineers told us that it would be a limit, a threshold, which should not be taken over. Again, of course, we could do the same for the ULS with addressing the bending moment in the sheet pile wall, for instance. And here you see it's an actual real case. So you see here the excavation, the strutting, the sheet pile wall. That's it for the introduction. So now